Hello developers and welcome back to Elixir Pro. In this video, we're going to continue our series on the Cold Wars exercises. We did an exercise on road to Q7, road to Q6, and this video, finally, we're going to start our road to Q5. Hope you like, and let's get started after the intro. So let's get started. As you can see, we are on the profile. We just reached the Ryuku 6. We are in the road to Ryuku 5. So let's start getting our first exercise. We already sorted by popularity, Elixir language, approve it, and we're going to just perform exercise from Ryuku 6. Okay? So let's get started for these multiples of 3 and 5. I believe it's parallels, we list all numbers. We will tend that are multiples of 3 and 5 to get 3, 5, 6, and 9. And the sum of these are 23. Okay, so let's get started. Let's open our code wars 6. Oops, 6. I believe that we already did this in the introduction of this series because it was our first. We actually have a lot of here, multiples of 3 and 5. Okay, so let's create like here. Multiples of 3 and 5.ex. But let's put a underscore 2 here. So 35 underscore 2. Okay, so mod. Let's grab the solution from here. Okay, let's paste it. Let's create a test file. Test mod. Okay, let's grab this content here, paste it, and this should go away. Okay, solution, and okay, I believe that's everything that we need. Let's actually open our code on the right. Let's get started. Okay, so first we need to generate all the numbers from 1 to that number. So 1 to number, right? Then we're going to filter for those which are which the rem is equal 0. So enum.filter fnx and okay. And this should be x. Actually, rem x3 equals 0 and rem x5 equals 0. I believe we get all of them, and now we just need to sum them. I believe that's everything that we need to do here. Sum. Let's run this test. And the left return 0, on the right return 23. So I believe we did something wrong here. Filter. Whoops, it's groups of 3 and 5. So 3 or 5. Okay, so actually we got this thing wrong. It's like this. And if we try once again, the left returns 23 and on the right return 33. So let's see what we are happening here. We go for this one, what we got. And sum is 8 plus 6. 13, 23, 33. Oh, and the 10 should go away. Okay, so it should be number minus 1. So once again, oops, and now I forgot the sum. Yep, it passed, so let's attempt. Let's format this thing. And attempt. And it worked. We can submit. Make this thing a little bit bigger so you can see. Okay, that's pretty much what we are doing. The RAM equals image summing. Yep. Here's where it's generating the event there. I piped. So yeah, pretty much the same solution. So let's go for our next kata. Okay, so if you refresh actually this thing here, we see we gain 5 point something%. So the next one is find the odd int. Let's go for this one here. So given an array of integers, find the one that appears an odd number times. Okay, that's pretty much, I think that's fairly easy actually. Number of times, so okay, 10 appears just one time, and this appeared twice, here just once, and actually this one here twice, this one here is twice, this one here, and -1 appears just once. Okay, I think it's easy as well. So find the odd int. I don't know if I did this in the past, but find the odd int.ex. Okay, now I created the file. Don't know what happened before. Okay, so let's paste this thing here. Yup. Test mod. Okay, let's grab this thing here. Oops. Let's paste it. So this should be find the odd int. This thing as well, this thing as well, this thing as well. Okay, and if we run this test case, it should fail, right? It failed. So let's go for it. I think I'm supposed to list enum dot. I think they can appear 3 times, right? Yeah. So it's basically item dot sort. Sort them. Then I'm going to enum.map. I'm going to, actually I don't need to sort, actually I just, oh no, yeah, I need to map them. Sort, don't need to sort, yes. Map, fin x, and then I'm gonna do, actually return a tuple, where the first element is the element, and then I'm gonna enum dot count the list then x then y equals x, and I believe that's it. I think this is going to return the tuple where the second element is on, so then I can do enum dot filter fn num times, and then I can return those which the RAM times 2 equals 1, right? Then we can do a map set of new. Actually, we can do that enum.unique. Let me see what this is returning for the moment. And return 5 and 3. So basically what we need to do here is to return this, where we wanna get the answer and the times, which we don't care, and super. And then we're just going to return the answer. Right, I think that's it. Yep, all the cases pass, so I believe that's our solution. Actually, you probably would find something more interesting in the answers for this one, because it was like pretty straightforward, but I believe we can solve this in a more Elixir-ish way or a more beautiful way. Let's check it. And look at that, we're probably gonna get our first timeout. So there is an easier way for us to do that. Okay, I think that's pretty interesting. Let me see how can we solve this in a better way. Okay, let's go for the list. Let's, instead of filtering, actually the thing that I want is to get the elements. So let's actually enum.group by, and let's go for each of those elements. So now we have them. They are grouped. Let's see how we. Oh, it's another way that we can do this. And then I think we can get the values map. So that's key value. Let's return just value. Key is not perfect. Yeah, okay. Now we got all of them. Then maybe we can filter by filter x at the length x rem 2 equals 1, and then we can get the head twice. Yeah, let's get the head twice list. Not first. And yeah, basically we did it. So go back here, let's grab it here. And let's go for the got an extra space here. Let's attempt. Yep, and now they are passing. Okay, so let's submit. Oh, see, we got the map values instead of ours. Enter.odd get, but it's basically the same thing as we did. Reduce map.update the count map to list, basically like the same idea. Remaining. Oh, this one here is clever. What is this bitwise? Let's check how the RD's operator working. It is using the shore. Shore bitwise. Actually, I need to think about these bitwise operations. Looks like shore is dividing. No, actually this return. Actually, I need to start studying. I don't recall exactly from university how shore used to work, but that's something clever. I like it. So let's put this best practice because you see how easy it was. The same thing as we did. Oh, this is ours. And find the odd. Actually, the one that I liked the most was this one here. Okay, so let's see. Probably we're something around 11% now. So let's get started in our next exercise. So katas and Ryuku, popularity, Elixir. Okay, sum of digits, digital root. Okay, digital root is the regular sum of all digits. That's pretty easy. Oh no, that actually it's iteration. I thought it was just like that, but then we have to do the same thing. Okay, so let's try it. Sum of digits. Dx. Sum of digits. Mod. Okay, let's create the test file, test mod. Okay, let's do like the test of the example. Test full. Instead of kata, this should be sum of digits, right? Sum of digits. Sum of digits dot digital root of what was the example? 16. 16 equals 7. Search. Let's run this one here, and we should see that it's giving new. Okay, so what should we do? We should get the n. We should then get integer dot digits, and then enum dot sum. This is like our n iteration. Okay, and then what can we do? We can do actually maybe we can do everything like case. Yeah, okay. Case and iteration. Yeah, integer dot digits enum length greater than 1 to end. Actually, this should be a count. It's a case as well. True. If this is greater than 1, then we should call digital root in an iteration. Otherwise, we should return the n iteration. Maybe that's it. Run for this one here, and it passes. Let's go for grab like the next one, more 942. So 942 equals 6, and it passed. So let's go for this one here, and it passed. So I believe that's it. That's our code. Can we make this thing even better? Maybe that's good enough. So let's check if we do not get the timeout that we received just now. let's yeah. Oh, and he passed, and it was pretty easy this one. Maybe we can go for one more before we wrap up. So when it's lower down, and then some oh, this one, it's good one. You see, I like it, this one here. Probably there's a formula for this one, that is this thing here. So mathematics important for pure science. And then it's basically what we did here. It's our code. But the one that I liked the most was this one here. I'm gonna grab this one and paste at the bottom of our code. Yep. So let's go for our last kata for this video. Let's go back to katas. 6 popularity, and maybe we yep. So persistent bugger. What the fuck is this one here? Let's see. It's not like something weird. Write a function called persistence that takes a positive parameter, a number, and returns its multiplicative persistence, which is the number of times the number must multiply by the digits in number until you reach a single digit. So returns 3 because 3 times 9 equals 33. No, 27. And then 27 reaches 14. And 14 times 1 equals what? Just 4, which has just one digit. Single digit. I think that's fairly easy. Again, we can go for it. Persistent bugger. Okay. Let's go here. EX. Okay. Mod. Persistence. Let's make it a little bit bigger. I think that was too much. Yeah, let's go for it. You open mod here. Let's paste it. Okay. Bugger. Okay, what's happening here? Okay, so n, we go for integer dot digits. Dot reduce, if that's a good thing for reduce, and x acc x times acc and then what we do, if we this is an iteration and const. Actually, let's go for case and iteration integer dot digits. It's pretty much the same one as the one before, right? If length greater than 1 to n. If this is true, we are gonna call just need to pass an accumulator. I'm gonna call persistence, and then we're gonna be calling with an array of 1. So actually, let's do something like this. Persistent with n, we can go for it's called persistence, calling n and 1, and then we can go for def t and acc, and if this is true, we can go for passing persistence and iteration acc plus 1. Otherwise, we can go for the acc. If we run this thing here, left 0, so we can go for, let's see, let's start with 0, maybe that's the way to go. And then we should return acc plus 1. This should be acc, I guess. No, so have to make some, let's put some effort in it. Okay, so 39. 3 times 9. 3 times 9 is 27, so 27. 27, 2 and 7, and return. So 27. 27, and now we have plus 1. 27. We can actually do this. And minor than 10 do 0. Okay. So 27, and now we have 1 there. 2 and 7, 14. 14 is 1 and 4. It's greater than you, so 2. 2. So now I have 14 here and 2. 14. 1 and 7. 1 times 14. Sorry, 1 and 4. 1 and 4 equals 4. For this greater than 1. False. False. Maybe now we have it. Yeah. So there we have it. Can we break this thing into this true and false here? Maybe we can break it in other clauses. So instead of case, this should be like if, right? If do this, else. It's interesting. And then I think that's pretty good. Let's check how everyone else did their implementation. Okay, so let's attempt and submit. Okay, this one looks easy already. So integer.digits. Got it. This thing here is a single digit. So whenever this thing matches, this thing is a single digit, I'm gonna return the I, which is the time of man. This one here is awesome. This one here is awesome. I'm gonna put it down below. Well, that's it for this episode. Thanks for watching, and until next time, we're probably gonna do the same type of exercise on the Brazilian channel. So if you wanna check there, just like following the code, be my guest and support the channel as well. Thanks for watching, and until next time, bye.